children, welcome back to the class. We are dealing with sets. Yesterday we have seen the definition of sets and we were able to identify what are sets and what are not sets, right? So that was our yesterday's concept. So today we are going to see what is set and its types. We're going to deal with types of sets, and that also we have seen in the last class. Based on that concept, we are going to explore a lot of sums today. So let's quickly move on to the concept. So we'll just recall what are sets first. So what are sets? Set is a collection of well-defined, distinct elements, and you can give example also for that. I have taken the example as A is equal to 1, 3, 5, 6. It's a collection of 4 elements, that's all. So each 1, 3, 5, 6 are called elements, and always the elements we will write it inside the flower bracket, and we will use a capital alphabet to denote the set. So all this we know, and we have seen the representation of sets also. What are they? Do you remember? One is the roster form or the tabular form, and the another one is set builder form, right? So what is roster form and what is set builder form? Roster form is all the elements are just listed inside the flower bracket. For an example, A is equal to set of all elements A, E, I, O, U. Okay, so here in the set A, all the elements are listed, separately listed with a comma. So we'll call this as roster form. We have another form which is set builder form. What it is? Written with a single common property. All the elements will not be listed separately, but the elements will be written with its common property. What is a common property? Where all the elements possessed, that will be written in words. That is set builder form. For example, we'll denote set builder form like this: A equal to X, such that we will read this colon symbol as such that X is a vowel in English alphabet. So what are vowels in English alphabet? It is A, E, I, O, U. Am I right? If you see this example and this example, both are denoting the same elements only. Whereas here it is written, it is listed, here it is just written the common property of all these 5 letters. The common property of all these 5 letters is they are vowels in English alphabet. So we'll just write the common property where all the elements possessed. That is what is set builder form, right? So these are the things we have seen yesterday. Let's learn new thing today. So we'll start with a symbol learning. We're going to learn one new symbol today, which is belongs to. Okay, if I put a symbol like this, we will read this as belongs to. If there is belongs to, does not belongs to also will be there. So we'll denote that element as does not belongs to. We will denote it like this. Okay, so these are the 2 symbols we are going to learn today. So what do you mean by belongs to with respect to sets? I'll take one example of set here. Set A containing the elements A, B, C, D, E, F and G. Okay, now when will I use the word belongs to and when will I use the word does not belongs to? We'll see that. Now here, if I take one element from the set, I'll take one element. For example, I'm taking A here. A is an element which belongs to the set A. Very good. So A belongs to this set. So I'll just write A as A with the belongs to symbol A. Got it? So that is where we will use this belongs to symbol. I'll take for does not belongs to. If I take one letter H, whether it belongs to the set? No. H is not there in this set at all. So I'll write H does not belongs to the set A. I will denote it as H does not belongs to symbol A. Okay. So it means what? H is not there in the set A. Got it, children? So this is the new symbol we have learned today. So let's try one. Okay, I'm going to give you one set for you. A is equal to 1, 2, 3, 4, 5, 6. Okay, so now you're going to tell me whether the element what I've given here belongs to that set or does not belongs to that set. Quickly, 5 is there? Yes, 5 belongs to A. 8, of course 8 is not there in the set, so 8 does not belongs to A. 0, again 0 is not there in the set, so it does not belongs to A. 4 is there, so 4 belongs to A. 2 also is there, so 2 belongs to A. What about 10? 10 is not there in the set, so 10 does not belong. So we know very well the types of sets. Now it's time to check our understanding. I'm going to give you few forms and you are going to translate it into another form. Okay, so we'll see that. Write the following sets in roster form. Okay, we are going to write it in roster form. It means we are going to list the elements. What form is given here? It is in set builder form. Okay, so we are going to convert set builder form into a roster form. Okay, are you ready? Yes. So read the first question. A is equal to x such that x is an integer and the integer should lie in between -3 and 7, and look at the interval here, -3 less than or equal to x. Okay, so -3 is included. It should be -3 less than or equal to x, which is less than 7. So what is the limit for x? It is -3 to 7. Just recall your number line, integer number line. It's starting from -3 to 7, where -3 is also included. What about 7? 7 is not included. X should be less than 7. It should not be less than or equal to 7. Remember, see the symbol clearly. X should be less than 7. At the same time, x should be greater than or equal to -3. Now can you list the elements? Recall your number line starting from -3, that is from left side. You have to move forward to right side till 7, where 7 is not included. What are the elements will come? I think you would have got the answer now. So the elements are -3, -2, -1, 0, 1, 2, 6. Okay, so these are the elements will come in this set. Understood? Easy? Yes. So we'll see the second question. B is the set which is x such that x is a natural number less than 6. Very simple, very simple. Less than 6, what are the natural numbers we have? It is 1, 2, 5, 3, 4, 5. That's it, 1 to 5. Got it? It's very simple again. Third question. X, C is the set which has x such that x is a 2-digit natural number such that the sum of its digits is 8. So it is a 2-digit number and a natural number. If I add the digits, I have to get 8. What are the possibilities? Yes, 1, 7, 2, 6, 3, 5, 4, 4. Yes, very good. So 1, 7, 2, 6, 3, 5, 4, 4, 5, 3, 6, 2, 7, 1, 8, 0. After that, it will become a 3-digit number. So these are the 2-digit number, possible 2-digit number. When you add the digits, you will get the sum as 8. Easy? Yes. We'll see the next question. D is a set such that x is an element such that x is a prime number which is divisor of 60. So what are the prime numbers we have that you should recall first? 2, 3, 5, 7, 11, 13, like that. Okay. Out of those prime numbers, which are the number is divisor of 60? Which are the number will divide 60? 2, 3, 5. Any other prime number? Any other thing? No, we don't have any other number. So the elements will be 2, 3, 5. So these are the 3 prime numbers will divide 60. Other prime numbers will not divide 60. Easy? Yes. So some problems are waiting for you also. We'll move on to the other type. Roster form will be given. You are going to write the common property. Okay, in statement you are going to write it. We'll see the questions. Write the following sets in the set builder form where the elements are given to you. Okay, so I'll take the first question. 3, 6, 9, 12. What do you think the common property between all these 4 elements? There are only 4 elements. What will be the common property of these 4 elements? It's all multiples of 3? Yes, so 3 into 1, 3 into 2, 3 into 3, 3 into 4. So I can write the common property as x. I can give one name for the set, like capital A is equal to x, such that x is equal to 3n, or we can write x is a number multiplied by 3. In statement also you can write, and we have only 4 elements. If you stop with this, it will be like a infinite set. So we have to write n takes how many natural numbers. So here n is 1, n is 2, n is 3, n is 4. So n is lying in between 1 to 4. That interval you have to mention it very clearly. If you stop with x is equal to 3n, then the set will be having infinite number of elements, whereas here we have only 4 elements, so we have to write the condition for n also. So limit for n is 1 to 4, where 1 and 4 are included. So we will represent the limit like this: 1 less than or equal to n less than 4, where n is a natural number. All these conditions, these are the properties of all these 4 elements. So everything has to be listed properly. Clear? Yes. Second question, can you try? 2, 4, 8, 16, 32. What will be the common property? What is the relation between these 5 numbers? All are, yes, exponents of 2. Okay, 2 power 1, 2 power 2, 2 power 3, 2 power 4 and 2 power 5. So what will be the general form of this? X is equal to 2 power n, where n's limit is 1 to 2 power 1 to 2 power 5. So n is 1 to 5, where 1 and 5 are included. So less than or equal to symbol we will use. So 1 less than or equal to n less than or equal to 5. Got it, children? So this is the set builder form for this question. I'm going to give you third question as your task today. We'll see the fourth question now. 2, 4, 6. What is the relation? Multiples of 2. Very simple. 2 into 1, 2 into 2, 2 into 3, and look at the set here. It is infinite set, so you no need to give limit for n. So x is equal to 2n, and n is a natural number. That's all. You can stop with that. There is no limit for n. It's an infinite set. Okay. Fifth question. Okay. 1, 4, 9, 10. All are perfect square numbers. So 1 square, 2 square, 3 square, so on. What is the square root of 100? It is 10 square. Okay, so we'll just write the common property as x is equal to n square, where n starts from 1 and ends with 10. So n is a natural number. Capital N means natural number, children. So n belongs to capital N, that is the number n belongs to natural number, and the limit for n is, it is lying in between 1 to 10. Understood? Yes, so you're very clear in converting set builder form to roster and roster form to set builder. Am I right? Yes, super. We'll move on to the next concept now. So some more task for you now. List all the elements of the following set. Okay, again, set builder form is given to you. You need to identify the elements of the set. I will see the first question. B is equal to x such that x is an integer. Okay, it is only collection of integer, where the limit given to you is minus 1 by 2 to 9 by 2. Okay, minus 1 by 2 less than x less than 9 by 2. Okay, minus 1 by 2 and 9 by 2 are not included. Less than or equal to is not there. Okay, so in between this interval we need to identify only the integer and list. So this given these numbers are what type of number? It is a rational number. In between these rational number we need to identify only the integers and write the numbers. So ready? Yes, minus 1 by 2 means what is its decimal form? It is minus 0.5. 9 by 2 means it is 4.5. Now just imagine your integer number line. Minus 0.5 and 4.5 is your extremes. In between, what are the integers you can identify? After minus 0.5 towards right side you have 0, then 1, 2, 3 till 4.5 you can reach, but not greater than 4.5. Before 4.5 what is your immediate integer? It is 4. So your elements in that set will be 0, 1, 2, 3, 4. Very simple? Yes. Your next question, c is equal to x such that x is an integer, and if you square that x it should be less than or equal to 4. All collection of integer, if you square that integer it should be less than or equal to 4. What are the numbers will satisfy this condition? It should be an integer. 0, 1, 2. Am I right? 0 square is 0, 1 square is 1, 2 square is 4. 4 can come. Less than or equal to is there. Since it is an integer, again its opposite sign also will come. Minus 1 square is also 1. Minus 2 square is also 4. Am I right? So from minus 2 to 2, all numbers will be satisfying this condition. So your set elements will be minus 2, minus 1, 0, 1, 2. Just square it and see whether this is applicable to these numbers. Minus 2 square is 4. Minus 1 square is 1. 0 square is 0. 1 square is 1. 2 square is 4. Apart from that, any number you write, it will be greater than 4. So we will limit with this. The next question, E is a set. It has the element x such that x is a month of a year not having 31 days. So which are the months not having 31 days? Just list out. Very simple question. So the month of a year not having 31 days are February, April, June, September and November. So just write all this month in a flower bracket with commas. Just give one capital letter as a set name. So here E is given, so E is equal to. Simple? Yes. Now one more small task for you. Match. So here roster form is given, here set builder form is given. You need to match 1, 2, 3, 6, 2, 3, MATHEICS 1, 3, 5, 7, 9. Here x is a prime number and a divisor of 6. X is an odd natural number less than 10. X is a number and divisor of, X is a natural number and a divisor of 6. X is a letter of the word mathematics. Very, very simple question again. 1, 2, 3, 6. What are the numbers? X is a natural number. In this, if you see, it is the divisor of 6, right? 2 and 3 is a prime number and a divisor of 6. MATH, very simple. It is all the letters in the word mathematics. 1, 3, 5, 7, 9 is an odd number, natural number less than 10. Wow, super. So with this we are completing our class. Now this task is for you. Just read this question, just the conversion. These are all in set builder form. You will write it in roster form, and this is in set builder form. Again you will write it in roster form. So these two tasks are for you. You will post the answers in the mainstream. Okay, I'll be waiting for your answers, children. Come on. Thank you, children.